All right, so today we're going to become architects of the 2D plane. We're cracking open the geometer's toolkit to figure out the secret language of straight lines, turning these simple-looking equations into, well, infinite possibilities. I mean, it really does seem like magic, doesn't it? How can this one little string of letters and numbers hold the entire blueprint for a line that stretches on forever in both directions? Well, today, we're going to crack that code. We're going to show you the logic behind all that magic. So let's get right into it. This equation, y equals mx plus c, you've got to think of it as our master key. Once you understand its parts, you can unlock the secrets of pretty much any straight line in the universe. Now, this little letter M is what gives a line its personality. It tells us everything about its character. You know, is it a super steep climb, a really sharp drop, or just a gentle slope? That's the gradient, and it's absolutely key. Okay, so if M is that important, how in the world do we actually find it when it's all buried inside a jumbled up equation? Well, that's our first mission, to yank that gradient out, no matter how it's disguised. So here's our first challenge, taken straight from our source material. We've got the equation 3y plus 2x equals 5. The gradient we're looking for, it's hiding in there somewhere, so let's go find it. Okay, so here is the golden rule, the one thing you have to remember. To find the gradient, y has to be all by itself on one side of the equation. So our whole job here is just to get y alone. First, we'll move that 2x over to the other side by subtracting it. Then we divide everything by 3 to get y completely on its own. Now, look closely. The number that's right there next to x, that's our gradient. And boom, there it is. The gradient is negative 2/3. Awesome. Tool number 1? Check. It's in the toolkit. Okay, tool 1 is locked and loaded. Now for tool number 2. What actually happens when a single specific point in space meets one of these infinite lines? This right here is like a fundamental law of the universe for coordinate geometry. You can think of it like a password. If a point's coordinates, its x and y values, make the line's equation true, then boom, it's granted access. It lies on the line. If not, it's just an outsider. All right, let's put this rule to the test. We're told that this line passes through a point where x is 5, but the y-coordinate, well, it's a mystery. We'll just call it k. To figure it out, we're going to use that golden rule we just talked about. See, because we know the point is on the line, its coordinates are basically the password to unlock the equation. So we just plug in 5 for x and our mystery value k for y. And just like that, what was a geometry problem becomes a simple little algebra puzzle. And the algebra tells us the truth. A few simple steps, and we see that k has to be -1. So the point's full coordinates are actually 5, -1. And just like that, tool number 2 is mastered. All right, so we've handled single lines. But what about when two lines meet? And I don't mean just meet anywhere, but what happens when they cross at a perfect 90-degree angle? This is super important. For parallel lines, it's pretty easy, right? They're going in the exact same direction, so their gradients are identical. But perpendicular lines, now they have this really cool special relationship. If you multiply their gradients together, you always get -1. It's like one line slope is the perfect geometric flip of the other. This rule is our third tool. Okay, let's use this new tool. Remember that very first line we worked with? We found its gradient, our m1, was -2/3. So our mission now is to find the gradient of any line that's perpendicular to it, and we're going to use our new rule to do it. We're literally just going to follow the rule. We start with our formula. m1 times m2 equals -1. We swap in the gradient we know, -2/3, for m1. To solve for m2, we just divide -1 by -2/3, which is the same as flipping and multiplying. And the result? The perpendicular gradient is +3/2. Okay, this is the moment. This is where everything we've learned comes together. We're not just taking lines apart anymore. Nope, we're going to build a brand new one, completely from scratch. So let's take a look at our toolkit. We've got the gradient we just found, 3/2. The source material tells us this new line passes through the point -8, 7. And of course, we've got our universal blueprint, good old y equals mx plus c. The only thing we don't know is c, the y-intercept. But that's no problem. We can totally find it. We're going to do exactly what we did to find k. We just substitute everything we know into the blueprint. Y is 7, m is 3/2, and x is -8. The only thing left to solve for is c. So when you do the math, it simplifies down to 7 equals -12 plus c. A little bit of rearranging, and we find that c is 19. That was the last piece of the puzzle. So now we just take our gradient m and our new y-intercept c, and we plug them right back into the blueprint. And there you have it. Y equals 3 over 2x plus 19. We just built an entire equation for a line from scratch. How cool is that? All right, one final test for our new toolkit. The source gives us 2 points, B and C, and it tells us the gradient of the line that connects them. But here's the catch. One of the x-coordinates is a mystery. It's just called P. Let's see if we can figure it out. Okay, so here's the big idea. We actually have 2 different ways to think about the gradient here. We can calculate it ourselves using the formula, the change in y over the change in x, and we're also given the value, which is -3/4. Since they're both describing the exact same line, they have to be equal to each other, and that gives us one last equation to solve for p. And solving that final puzzle pretty much brings us to the end of our journey today. We've decoded gradients, we've verified points, we've figured out perpendicular lines, and we even built a line from the ground up. What you've done is build this incredibly powerful toolkit for navigating the world of coordinate geometry. The tools are officially in your hands. So the only question left is, what other geometric secrets are you going to lock?